Hey, what's going on, guys? Here in this video we will implement user controls so that when the user presses the arrow keys on his keyboard, our tetromino is going to be moving like left, right, down, and on pressing the up arrow key I want to rotate a single tetromino. So without further ado, let's actually dive into the code. So here is the output that we have since the previous part, right? So we already can specify the position X and position Y coordinates for this tetromino to be displayed on the board, and also we can rotate it as well using the current shape variable, which takes the values from 0 to 3, like four values like 0, 1, 2, 3, and they do correspond to 0, 90, 108, and 270 degrees. So now we need to bind the key press event to the document. And let's go for it. So here we have the user input controls, and let's define, it's not a function, so here we need to say document dot on key down. So I'm going to be tracking the on key down event, so every time user presses the key, so this event fires. So it's going to be equal to the function. So here is the callback function I'm now defining here, and it takes the event as an argument. And now here I just want to say console.log and event.keycode. So since the arrow keys don't have the ASCII values, we just can rely on the key codes. Now update and Control-Shift-I to see the console. And now already, so if I press, no, sorry, not like this. Yes, if I press up, down, left, and right. So you see here, this numbers appears, which are the key codes. So we can track this, so up, down, left, right, by using this number. So what we need to do now is to simply say like switch and event.keycode, right? And here we have case, 38, which stands for, so this is up arrow, then case, yeah, it just keeps, I'm pressing the buttons, it keeps listening. So 40 goes for down, so 40, this is going to be down arrow. Then case 37 is left, 37 left arrow, and 39 is right. So case 39 is right arrow key. Okay, so far so good. So we no longer need this. Okay, and now all we need to do, well, I hope this time inserting breaks should kind of work unlike with the previous time. So yeah, so just add this breaks. Since we are not returning anything, we just want to break out here when the event fires. Okay, so up arrow. So up arrow is responsible for rotation, so probably let's kickstart with this one. There would be some additional code that regards to the collision detection, and that code would be added here as well. Yeah, and probably I'm into this user controls to figure out if the collision detection occurs or not. But the function to detect the collision is obviously going to be separated. So now let me just prettify the code a little bit to put the indentations here. All right, so for rotation we also need some additional logic to distinguish between the piece types we are about to be rotating, because some pieces we want to rotate like all the 4 directions, but others only 2 directions. Okay, so up arrow, and we'll start right over in here. So the very first, the simplest thing that we can do, we can simply say current shape plus plus, and that's it. So we're going to be changing the rotation. It would result in errors now, but I just want to give you an idea. So now I'm pressing the up arrow key and nothing happens. Okay. All right, that's because okay, so no, nothing happens because I do not I don't re-render the board. So apart from this, I think, yeah, we just draw the Tetromino here. I think that it's also time to start writing a game loop. So for our game loop, we need to draw the Tetromino and kind of render the next frame. So let's go for this quickly here. So here, game loop or main game loop, function game loop. Yeah, because otherwise it's just not going to be working. So here, I want to actually draw the Tetromino. It's the very first thing to consider. And after, I want to say set timeout, and let's take it to, let's go half a second, for instance. Well, this number would affect the speed of how fast the Tetrominos are about to be dropping later on. But for now we can just make it as is. We can even, yeah, let's just keep it like so. And here we call the game loop, but it's not called recursively. It would just kind of be calling itself in the background forever. And that's the way how we can handle the game loop. And then above this, the rest of game loop logic is coming also. Okay, so let's refresh, and yes, probably error. Nope. Oh, that's because okay, I obviously need to call the game loop here. So let's say run Tetris and game loop. And here we go. So now press the up. Okay, so it does react to pressing the up key. However, it doesn't behave properly for some reason. So let me check. Yeah, and also I just want to get rid of this. I don't want to log anything to console here. Okay, another thing I forgot to do. Well, actually, after here we want to update frame, and I just say draw Tetromino here as well, because when it changes we want to re-render it from scratch, because that's how the rendering works. Yeah, I'm a little bit confused by the fact why it draws all of those things. No, it's not exactly what I was looking for. Okay, so one of the possible issues, because we already have current shape equals to 3, yeah, it's probably just goes for an indexing error part everything else. So let's have a look here. Okay, so now finally we go for it, and yeah, then this error because we need to wrap around the indices. Okay, so yes, here I can say if current shape is less than 3. In this case, I want to say current shape plus plus. Otherwise, I want to set current shape to 0. So this helps us to rotate around our, like, go for a never-ending rotation of our Tetromino. So if I did everything properly now, it actually should. So I press the up key. Okay, and now you see like Tetromino goes, it rotates like forever. It's not centralized. Well, that's because we have the 4x4 elements here. But for the from the practical perspective of the gameplay, I really love this more than if, say, it would be rotating over this one. So I really think that this kind of rotation is more practical, and I really like it more. So we're going to be sticking to this one. Okay, so it works perfectly well for rotating pieces like this. And now let's see the other Tetrominos. So this is the last one. So this is Tetromino 6, tetromino 5, update. So rotating clockwise, okay. And now tetromino 4, update. So this piece just look in another direction. So this is also okay. All right. But when it comes to tetromino 3 and less, so for instance here, you see like it goes, it slides a little bit because so this is not the same as this. So this one just one cell here, and this is one cell here, one cell here, one cell here. Why does this happen? Because that's how the rotated indexing works. So for this like pieces that do have their index which is 3 and less than 3, we want this number to be equal to actually 2. So here I'm using the list, sorry, not the list comprehension. I'm using ternary operator, and I just say current tetromino is less equals than 3 if it's equal to 3 or less than 3. So is it? And if it is, in this case, I want to consider only one direction. Yes, just only turn this once, and otherwise I want to turn it 3 times. So now let's update. Now you see like it only goes for two kind of shapes, and that's it, which is exactly what we want to have. Now, well, let's start from, actually from the very first one. It's not going to be interesting because this one can't even rotate. No, sorry, it's the second actually. So the first one, so this doesn't rotate, obviously. Then this should rotate only, yes, like this. Okay, only 2 positions, that's good. Only 2 positions here. 3, only 2 positions here, which is okay. And now 4, now this should rotate to all the positions, and it does rotate to all the positions, which is exactly what we've been looking for. Same this one, and same this one. Fantastic. So from now on, we can actually add the movements. So let's drop down to our user input control. And well, we don't, well actually, yeah, we can use this down arrow as well. So for now, as far as we don't have any collision detection, we just can change the coordinates of the tetromino. So here I just say position y plus plus to go down. Here to go left, I say position x minus minus. And here I say position x plus plus. So let's see if this kind of works. So update, so left, and we go left, and we go right, up. If I press up, it just rotates, and we can place it down. So we can actually place our tetromino exactly where we want. But here is the problem. So you see like it can go off board like this. So it doesn't have any collision detection. It can overlap through another piece. And in this case, it's really good to see this tetromino like being like a different color, because it's really gonna seem nicely visually. So just to recall from the previous, just say print board here, then you see like the board position didn't actually affect after. So you see like no matter that this guy is here, so we can move it around, we only print the statically settled down tetrominos here. So this one is to fit dynamically, and I emphasize this in every single video in this series. And when it comes to collision detection, which I believe is one of the most essential parts in the entire series, the way how the collision detection is going to be working would rely on exactly the same logic of how we did fit the tetromino into this board graphics. But instead of changing this kind of styles to highlight the corresponding cells, we instead would be checking whether the collision happens or not by referencing the actual Tetris board and not touching the GUI table IDs to highlight the colors. But that's gonna be the topic of the next tutorial already. So what we have achieved so far in this one is that we can move left, right, down, and we can rotate. So this is what we came up with so far. This is it from my side, guys. Thanks for watching. Until the next time, and take care.